for the discussion. Let me invite on stage my colleague, our editorial director of ProMFG Media, Niranjan Mudolkar, to be on the stage. Please welcome him with a round of applause. It's good to applaud, especially after lunch, because it burns about 27 calories per minute. Niranjan has almost 2.5 decades of experience in the trade media and publishing industry, and he is currently at the ProMFG Media, my colleague, as the editorial director. To join him, we have Mr. KVS Manian, whole-time director and group president of Kotak Mahindra Bank. So what happens when a banker joins the panel or on the stage, the average net worth goes up of the stage. Thank you, Mr. Manian. Thank you so much.
उनके नाम में ही मनी है.
Yeah, मेरे नाम में भी है, Manish. Mr. Deepak Pahwa will also join this panel. Please applaud loudly.
थोड़ा जोरदार तालियां बजाइए. आपके alumnus हैं. Sir, welcome.
Deepak Pahwa ji is the chairman of Pahwa Group, managing director of Braille Asia, and he is an alumnus, as Niranjan said, of IIT BHU. He introduced a dehumidification in India through his company Arctic India Sales, and subsequently he set up Braille Desiccant Rotors International. A great work, Mr. Pahwa. Thank you for joining this panel. We have Mr. Ramakrishna Singh joining us. He is the head business operations EV charging at Tata Power. Tata Power is also a partner of this conclave. Thank you, Mr. Singh, for joining the panel. Mr. Singh is a veteran, a power sector professional, and a change management expert. He has over almost 3 decades of experience with India's largest private power distribution utilities. With this, Niranjan,
thank you, Manish.
May I request you to begin the proceedings?
Absolutely. And I'm not going to start by talking about electric vehicles. सुबह से बहुत सुन रहे हैं electrical vehicles के बारे में, थोड़ा change करते हैं. So, as a young journalist, I had the opportunity to interview Dr. Varghese Kurian, the man who brought about the white revolution in this country. And I asked him a very cliched question, sir, when you thought about Operation Flood, White Revolution, what are the kind of challenges that you faced and how did you overcome? Very typical question that a journalist would ask. He said, Niranjan, मैंने challenges के बारे में सोचा ही नहीं. I asked him infrastructure, technology, finance, human resources. He said, I did not think about it. I had a vision in my mind. I had a goal in my mind. I pursued that and it gave me success. I think if the electrical vehicle ecosystem in this country has to succeed, that is the kind of mantra that we need to follow. There will be challenges, there will be issues, there will be problems. But there are people like these who are going to solve those problems. Yes, so let's start off with the money man, KVS. हम लोग सुबह से बात कर रहे हैं, we've been talking about technology, innovations, different things. Nobody has talked about money so far. So let's begin with this obvious question. What exactly is the role of finance in this EV ecosystem and how important is it?
So when I look at the ecosystem, in fact, I had told Niranjan that, don't ask me any technology questions. I used to be an engineer. Now I am more finance and commercial. So when I look at the ecosystem, of course, the charging infra, OEMs and the consumers is obviously the core of the ecosystem. Of course, in the next concentric circle, you could put battery manufacturers, power suppliers and things like that. And of course, in the outer circle, you will put government and policy makers and all that. So I see financial system sitting at the core of the inner circle there, right? Because many of you know that even the traditional vehicles, almost 80 to 90% of them are financed. When you buy vehicles, 80 to 90% of them are actually financed. So finance plays a very important role at the consumer end, obviously. So the way I look at it is the finance system has to solve for three parts here. One is the EV OEMs, second is the EV consumers, and the third is what I would call the charging infrastructure. Yeah, these are the three places finance has a role. As far as the EV OEMs are concerned, I think the biggest takeoff is in the two-wheeler, three-wheeler side of EVs, right? EV is not a monolith. It is it's two, three-wheelers as one set. Then I would say four-wheeler car as the second set. Third as the SCVs and commercial vehicles, the last mile provider kind of vehicles. And the fourth is HCV and buses, right? And each of them has a different issue. It's not, you can't solve all this with one kind of a solution. To my mind, the EV two-wheeler consumer is easy to solve. Actually, as a financier, we are very happy to finance, right? Whether we finance, in fact, today, about of scooters type of vehicles, it is, I would say 10% of that volume happens in EV. And we see that in our own financing. It's easy to finance. In fact, the profile of that customer is generally better. We are happy to finance. So I think it's easy to solve. It's also easy to solve the SCVs and the last mile because they are very commercially viable borrowers because the asset is commercially viable, and we have always seen when you finance a viable asset, it's very easy to get money back. So it's easy to finance. Again, nothing much to solve. I think it's just getting used to higher volumes and doing them. Cars, as on today, I think the buyer is a second car or a third car buyer, and therefore the profile of the customer is very high. So we have no problem financing it. But to scale it, I don't think this is the model that will work because the economics of the car side is not yet convincing, right? Only people who are passionate about this EV and environment are doing it. HCV, LCV is far from there. Buses will be more a government issue, can be funded. So if I look at that, OEM, consumer is easy to do, largely easy to do. The OEMs, today we have in the two-wheeler some 50 suppliers. I think in the final analysis, as a banker, when I look at the risk, not more than 5 or 10 will survive, right? So there is a huge risk there. So it's a private equity game, not a banker's lending game, right? So, but money is available. We have seen phenomenal interest of private equity players wanting to come and put money in that business. And the third is the most complex in my mind, charging infrastructure, because on that, we will talk through the session and Mr. R.K. Singh will throw more light at it. Because it is Tata's, we will finance them. That's fine, and we do. But
You are on record.
yes, I am on record. That's not a problem. But I think the business model around charging and the issues around how this business will evolve, how should we model, how do we think it will evolve, is a big issue. And I think still, I would place a lot of uncertainty on that side.
Yeah.
So that's broadly.
Let me just interrupt. Very, very well said, sir. Yeah, Niranjan, there is a development. Mr.
Okay.
Vani Dantam, who was to join this panel, he has traveled all the way from US to India. Unfortunately, his parents are not well, so to look after them, he is currently in Andhra Pradesh, south of Vijayawada, and he would be joining this panel discussion virtually through a Zoom call.
Wonderful.
So Vani Dantam also is an IIT BHU alumnus. Yeah.
Good afternoon, Mr. Vani Dantam, and welcome.
Can you hear me okay?
Yes, absolutely. Loud and clear.
Awesome. My pleasure to be with you.
Thank you so much. Can we have a round of applause for your alumnus, please? Mr. Dantam, since you are joining online, with the permission of my two fellow panelists, I'll come to you first, so that in case there is a technical glitch, we don't have to waste time there, right?
No worries.
Yeah, so Mr. Dantam, you have been in the charging infrastructure business or segment for more than 15 years. You worked across 4 different companies. But today, charging infrastructure is one of the biggest pain points for this industry. So,
It is.
what kind of challenges do you foresee, particularly in the ecosystem of India? I know you're based out of US, but what is your perspective about the Indian charging infrastructure, and how can we overcome these challenges?
Interestingly, the difficulties that we face with regard to the charging infrastructure are very similar, both in the US and India. The first and foremost problem is the government officials and the regulatory agencies are not really comprehending how difficult the problem is. I have worked with both utility industries and also with automotive industries. And within the utility, it's not very difficult because majority of the utility applications are based on, how do I say, a slow discharge, 4-hour plus. And so charging utility installations is not that difficult. The 2 applications where the battery charging becomes much more, hectic is frequency regulation applications and also buffering applications if the batteries happen to be discharged, because they need to respond very fast. And if you take the automotive applications and divide that again into what do you call 2-wheelers, 3-wheelers, and also 4-wheelers, and then commercial vehicles and buses or specialty vehicles, you'll talk about golf carts and industrial vehicles. The most difficult problem is going to be passenger vehicles. The 2-wheelers and 3-wheelers, the typical batteries are anywhere between 1.5 to kilowatt hours to 7 to 8 kilowatt hours, depending on the kind of technology you use. And you can pull these packs out and take them home or take them to your shop and charge them. 3-wheelers are fighting this problem with using 2 or 3 packs, and the commercial vehicles and buses, on the other hand, you can go to the shop. Pull the whole pack out if you can, and then replace it with a fully charged pack. It is the passenger cars that are going to be troublesome because this is where the lack of charging infrastructure or lack of proper charging infrastructure combined with the range anxiety is going to cause a lot of problems. I mean, you take, United States, I'll compare both markets. You take Tesla, for example. You have a 80 to 100 kilowatt hour battery pack in high-end Tesla, and let's say you have a 5 to 10 minute recharge capability for the Tesla pack to go from 0 to 80%. That means you're going to recharge anywhere between 50 to 80 kilowatt hours in 10 minutes. What does this translate into? It translates into having a 0.5 megawatt to 1 megawatt recharging line just for that one car. Is that possible? There's no way, unless you totally redo. And I have seen stats in the US. I'm sure the stats in India would be very similar or probably much worse. In any neighborhood, if our penetration, EV penetration increases by more than 10 to 20%, that substation for that neighborhood cannot support the additional load, period. And I had worked with National Grid in the Northeast, mainly in the Massachusetts area, and they go through this duck-back curve, and we've seen neighborhood after neighborhood maxing out, and they haven't even started EV penetration. And in India, most of the cars are parked on the streets and not in the garages. So how do you recharge them? So have the regulatory agencies realized, what is needed here and how severe the problem is? And it is our responsibility as industry experts to make sure the right people understand the severity of this problem, or develop car designs where the charging infrastructure becomes less of an issue, where you're combining, plug-in, hybrids, or fuel cell plus EV, or you're looking at solar plus EV. I'm just giving the options. If you switch to 100% EVs for four-wheelers, we are going to create such a massive problem. I don't think we understand how big the problem is going to be. And then so that's my take, gentlemen.
Thank you so much for highlighting it. I'll come back to you again talking about the battery part of it. But since
Sure.
you raised a very pertinent question about the capacity of the power infrastructure in the country to support the growth of the EV system, let me talk to the right person here, Mr. R.K. Singh from Tata Power.
Yeah.
Very important point that he noted is that if there is a 10% growth, our substations will collapse. So what is your viewpoint, or rather your comment on this point? As a power industry, are we ready to face that kind of growth in the EV sector?
Yeah. So thank you, Niranjan, and thank you, Mr. Dantam. I think very valid point, this power, because you are shifting the, crude oil, migrating from ICE engine to electric vehicle. So India has targeted by 2030, they want to have 30% penetration of electric vehicle. So you can think of the amount of energy going to, flow through the electric wires, generations, transmission, everything. So I'm not sure as of now that power industry is ready for this kind of massive power requirement. But yes, the solution is upcoming. Ministry is aware. Niti Aayog is aware. They are working on this. Even recently, Ministry of Power has issued the guidelines for setting up the power charging infrastructure. They are also facilitating through certain policy. There is a revamped distribution sector scheme. RDSS scheme is going on right now. So they are making, giving the options to making the smart power, transmission and distribution both. So through technology intervention and innovation into the power sector, I think this need can be addressed very well. For the comfort of audience, and since morning I was listening that there is a range anxiety, people are, worried that they don't want to buy the car because there are no chargers available. So for information of all of you, that Tata Power has set up almost 3,000 plus charging stations across India. You can travel from Kashmir to Kanyakumari. You can travel from Arunachal Pradesh to the Porbandar. You will find the charging stations across the roads, all major highways. So we plan to cover all major highways, state highways in years to come. So we are present into the home charging solutions, public charging solutions, fleet charging solutions, and bus charging solutions. So as of now, around next financial year, we would be adding another 4,000 plus charging stations. And by 25, we would be adding total charging points around 15,000, in the range of 15,000 or so. So I'm sure, and I request all of you to, I think, promote switch to e-mobility from the ICE, because even government has mandated that by 2030, the energy mix would be 50% renewable sources. So even though you are polluting, say, from 100% to 50%. So whether it is, and also that particulate matters and NOx emissions to the dense areas, thickly populated areas, Mumbai, Delhi, Chennai, it would get eliminated at least in the range of 70 to 80% as per the Kiwi study of 21 report. So it is a very valid, I think, point to migrate from ICE to these electric vehicles.
Thank you, Mr. Singh. Mr. Pava, first of all, tell me, how does it feel to be amongst your, university mates, classmates, and your friends?
Very good. In fact, it's always a pleasure to be amongst them. And
If your charges no.
no, this is
That's fine.
working.
Yeah, okay.
Yeah. And I think today's conclave has been very well put together. Excellent, and Sanjeev and you and the whole team has done a great job. He was running this idea past me a few months ago, and he's worked, and everyone's worked so hard to make it successful. That's what I can say.
Thank you so much for that. So I have a question for you. You are a pioneer when it comes to developing indigenous technology. So are you doing something when it comes to development of the right kind of battery, or at least provide a support system to the battery manufacturers in this country?
Okay. Before I answer that, I think I'd like to give a little bit of an overview on a few things. First, this word anxiety, since morning, since I was traveling from Rajasthan today, I've heard the word anxiety when this whole program was live several times. Very interesting. Normally, I've never heard this word used so often as it is in the context of EV. I bought 2 EV cars last month. I had no anxiety. I had no anxiety at all. However, I went to Rajasthan on Sunday, and from 100% charge, it dropped to 31% charge by the time I reached my destination. And I was a little bit anxious, but fortunately they had a charging station there, and then that was Tata Power. I struggled a lot because I don't know how to pay electronically. My wife does all that. So I managed to somehow overcome that challenge with good handholding provided by Tata Power. It was a good experience. Everything went well, and I got back in time for our program today. So I think the charging infrastructure is beginning to take shape. It's not very complicated. For the uninitiated, for the first charge, it will be there, but all good. Second thing, I would like to tell you all a name. Please make a note of this name. The name is Tony Seba. T-O-N-Y, Seba. Many of you might have heard of him. If not, just make a note, Google, and see if you have a presentation from him for 1 hour. In 2017, he made that. Excellent presentation. It'll make you, totally you'll be spellbound by that. In that, he starts with an opening slide showing Times Square, where there were horse-driven carriages, exactly 100 years ago. And it shows in about 10 years, there were only cars and no horse-driven carriages there. This is the level of transformation that took place in Times Square in the United States 100 years ago in a span of 10 years. I think we have to ask ourselves, are we facing something similar? Are we looking at something similar? There will be concerns, there will be consternations, there will be hurdles, there will be challenges, but I think we could be looking at something similar. There will be many, many things which are being discussed and will be discussed. And in that particular presentation in 1 hour, he talks a lot about autonomous cars. Autonomous cars are probably a little bit not as close as he predicted, but I think we'll be getting there. So there is a lot which will change in the landscape, which are the disruptors in autonomous cars, flying cars, which are not very far away. So we'll see how this whole thing pans out. There's a lot interesting happening. Now, the topic for today was new innovations in battery technology. And I was wondering why have I been called into that? Because I have very little directly to do in terms of battery technology, but I spoke to a couple of good friends in this industry. And I will telescope from there down to where I'm connected with the battery technology. So in telescoping that, I made a few notes. Lithium cobalt battery was first produced in 1991 by Sony in Japan, and the Nobel Prize winner in chemistry was given to Good Enough and shared with Akira Yoshino and Whittingham. That gentleman is still alive. He's 100 years old plus, but he is credited with that. Now, the technologies that have taken off are lithium cobalt oxide and lithium iron phosphate, which we have been referring to as LFP. Now, LCO is used mainly for laptops, tablets, and mobile applications, but LFP is very robust, safe, longer battery life, and is preferred by the Chinese because of the high density and less guarded. The technology patents are all gone. That's the reason the Chinese have gone totally towards LFP. The next generation is the nickel magnesium cobalt, which is NMC. This is highly guarded today. It's typically what you might call as patents are still valid. And these are also high density batteries, and the new cars coming from Europe are generally having NMC as part of the batteries. Talking to a chemistry expert, because at the end of it all, I mean, I think I heard someone say this morning 30% of the cost of the car is concentrated in the battery. And within the battery, 70% is concentrated into the materials. And within the materials, if you look at the changes that are taking place, it's essentially chemistry. A lot of work is going on in different parts of the world in terms of chemistry and the technology related thereto. But as I was talking to some of these material scientists who are teaching, understanding, who have worked with companies internationally, what to look forward to in another 5 years, they are all talking in terms of solid state batteries coming on. So that's something that we could look forward to, higher densities coming up, but this is where it may be headed. But as I said, I'm no battery expert. So I just painted a scenario for you for about 5 years from now, where it might lead to. But now coming back to the battery manufacturing per se, it has got 4 legs that it stands on. One is the materials, which you have heard about this morning very briefly. The second is the technology. Technology is highly guarded. And third is the machinery. And the machinery lines today are actually very well produced by 1 or 2 good Chinese companies, and they are being supplied all over the world, even by the Korean technology partners. Those have gone into huge lead times. So people who are scrambling in India to put up lithium cell manufacturing lines, one of their biggest hurdles is getting the machinery in time. You're talking about 2024 before they can get a proper line. So these are some of the challenges that are taking place. And of course, the fourth important one is the one where you produce the lithium cell. And that is where we come in as a company, and where my specialization comes in. That's called a dry room. Where you manufacture this has to be as low as -60 dew point, the environment in which the cell is produced. You have been hearing about explosion of these batteries. Lithium is highly explosive. You can't allow moisture to get in. So in those filling stations, when you're filling the battery with lithium, you need extremely low dew point air. And to control the whole air in this, now just imagine that you have to do this, but at what cost are you doing in terms of energy? In the entire lithium cell production, and which is part of the battery, almost 40 to 50% of the energy is just consumed in the environment control, not in the machinery. And in that, what controls that is what is called dehumidification equipment, which allows you to maintain -60 dew point. And that is where our company comes in, because our company holds 2 very leading patents globally from India for producing those environments at the lowest energy possible, 30 to 40% lower energy than competing technologies from Japan, Europe, and America.
Amazing.
So this is where I just wanted to telescope and let you know that how this has become very important, and one leg is fortunately totally available in the localization effort in India. I don't know whether I was invited because of that, but I have very little to do with the overall battery, just to let you know. Thank you.
Thank you so much. That was very lucidly explained, very educative. Thank you so much, Mr. Power. I'd like to come to KVS now. KVS, you spoke about the kind of support that banks can provide to the EV segment. Do we have the right kind of attitude in banks today? Are banks willing to support this EV system? That is number one. And do you think the government can play some role here in enabling banks to help the EV system?
Yeah. Many people make banks into gods. It is not true. Yeah, they are commercial organizations like all of us run them, and they also function for producing return to the shareholders and all of that. So banks will take risks that are commercially viable for them, correct? And if many times in an evolving situation, the business is not commercially viable, or it is not visibly commercially viable. And that's where the role of the government comes in, or support system comes in, where banks are allowed to, encouraged to do that. So I think this is a case, like I said, there were very clearly areas where banks are happy to do. The buyer side, the consumer side, we are most happy to do, we are already doing as much as we can. We are happy to do that. And I also told you that OEM side, it's difficult for banks to do because it's an equity risk. If 10 out of the 50 are going to survive, we are not going to put depositors' money into that, right? That is an equity play. The charging infrastructure, I feel that, bankers still don't understand the business model because there are doubts about whether it is going to be swapping, it's going to be charging, it's going to, nobody knows what the revenue models are going to be. So in this situation, in my mind, there are a few things the government and regulators can together do along with the banks. One is, that Reserve Bank and the government together create what they call the priority sector lending benefit to the banks, right? They get some benefits of doing, they are required to do priority sector. So if you classify these loans as priority sector, banks will do more of this because they have an obligation to do. So that's a regulatory intervention. Similarly, there can be interventions like subsidies, carbon credits for these as you, when exports, there was a time when banks used to get export subsidies. So if I lend to you at 8% or 6%, RBI used to give us 2%, and therefore it used to help us price it lower. Or risk sharing mechanism, like in the COVID times, government did for the MSME sector, where they, the ECLGS scheme, where they took risks and they said, okay, we will underwrite some portion of that. So the risk sharing mechanism can be created. They can create pools of capital which can be given tax benefits, right? So if I invest in the EV, we talked about the equity investments required in whether charging or in OEMs. If I invest in that, if that gains are taxed less or things like that, tax benefits can be given. And most importantly, I think, government can create, some countries have had a good experience doing that, create a nodal bank, which let's call it a green bank, a nodal green bank for the country. And the nodal, like the Exim Bank is for exports. And they work with the commercial banks and find ways of financing some of these projects where the risk is slightly indeterminate. Once, renewable, when we started renewable energy, since it's a related point I want to mention, today I don't think the banking industry is expecting subsidies on financing renewable projects, right? Solar projects. But if you went back 6, 7 years back, 8 years back, 10 years back, bankers weren't sure that they should be financed because there were too many things happening. So I think the enabling environment creation is absolutely essential, and that's where regulators and government can really play a role. Yeah.
Okay. Do we still have Mr. Vani Dantam with us?
Yes, I am.
Yeah, okay. Can we have him on the screen, please, console? Okay, while they're getting him on the screen.
I can hear you.
Yeah, sure. I'll go ahead and ask my question. Mr. Pava very elaborately explained the challenges as far as battery manufacturing and innovations in battery technology is concerned. As an expert in this industry, you've been working in this industry for the 15 years. What is it that we can expect from the battery manufacturers going ahead? Is the problem going to be solved? He mentioned about the anxiety that most of the customers feel. Can we overcome this anxiety from the industry point of view?
Good question. Good question. I actually wanted to comment on both what Mr. Singh has said about the charging stations and what Mr. Pava has mentioned. It is easy to build charging stations, but it is not easy to power them. We have to make sure, as we have more charging stations, they are powered amply, number one. So that is where the power supply comes. And what with Mr. Pava was saying with regards to technology, I agree with him 100%. It is extremely power-hungry manufacturing industry. And if we look at the way the lithium cells are made today, the electrodes are made, Sony and Panasonic did most of the work. And I don't know how many of you have seen a VCR tape manufacturing plant. I have. And when VCR tapes have gone the way of the dinosaurs, they actually adopted this equipment for the pasting lines of lithium-ion batteries. And the pasting lines are very long, very power-hungry, And we all heard what Mr. Pava said. There is a lot of work going on now to cut this down to size. I have seen technologies now in development. They will be out in the market in the next 2-3 years. The new pasting lines will be about 1/10 the size of what we are used to. And they will not require dry rooms. And so the power consumption for the plant is going to go down by more than 60-70%. And also because of their size, the overall CapEx budgets and the plant construction budgets are going to go down drastically. And that means we don't have to build gigaplants anymore. Currently, the break-even volumes for a plant are in the 2 to 3 gigawatt hour range. That can be brought down to 500 megawatt hours to 1 gigawatt hour. Imagine that. And also, what Mr. Pava was saying was about, having all this oxygen, right? There are new technologies where we can eliminate oxygen completely within the cell, because that's what sustains the thermal runaway. Because when the separator melts and the anode and cathode short out, the temperature goes up a lot, and your cathode is supplying all the oxygen because it has lithium oxide, manganese oxide, nickel oxide, cobalt oxide, and your anode has carbon, and you have fireworks. You go to technologies like lithium sulfur, where there is no oxygen inside. The company I work for, we specialize in lithium sulfur. So we do not have thermal runaway. And the cells are already certified for 65 degrees Celsius ambient. And so when you look at these technologies like that, for countries like India, where ambient operating temperatures are very high, these are very apt. So where is the technology heading down the road? Slowly but surely, we will eliminate nickel and cobalt first, followed by lithium oxide also, because currently lithium price is extremely, extremely turbulent. We all know that. And on a go-forward basis, we'll probably see the market getting segmented a lot more, depending on the application. And we all heard of sodium ion technologies, right? Utilities will probably switch to sodium ion very rapidly because extremely high life. You're talking about 4,000 to 5,000 cycles. The energy density levels are low, 150 watt hours per kilogram, but they're getting close to 200, which is very similar to LFP. Now you take the other side, automotive applications, you need to shrink the package. Tesla. The Tesla pack volume in the Model S is 350 liters. Out of this 350, what percentage does Tesla use to put batteries? The volume that Tesla uses 33%. That means 67% of the Tesla pack is non-productive. And majority of the volume is controlled by cooling systems. If you can eliminate that need for that very heavy cooling system, then you can put more batteries or shrink the battery pack. And that's where technologies like lithium sulfur come in. And not only that, lithium sulfur has very high potential. The energy density levels can be very high. We're just scratching the surface. We're at the bottom rung of lithium sulfur energy density capability. The theoretical limit is over 2,500 watt hours per kilogram. We're only operating right now at 350 to 400 in our company. So imagine the room to grow. So all of this, it's very exciting area. The market is going to get segmented depending on the application and depending on the safety requirements. But there are some things that are going to be obsoleted, which is the current way of producing cells and electrodes, and the current way of assembling the cells, and the current way of building the plants. The overall goal is to reduce the break-even point so more plants can be built instead of very large few plants. And number two, the safety of the batteries have to increase, and depending on the application again. So that's what I anticipate on a go-forward basis.
So you are expecting a huge paradigm shift in what's happening right now. It's not going to
Yes.
stay the way. Okay. Yeah, yeah.
Yes, I do.
R.K. Singh ji, a quick question for you. Pava ji ne bataya ki he had a very wonderful journey from Rajasthan to Delhi today afternoon, and he did not have any anxiety because of the charging infrastructure created by Tata Power. So that's actually a commendation for you. So can we expect that kind of charging infrastructure across the country, and by when?
Yeah, that is what I said, that right now we are ensuring that anybody traveling from Kashmir to Kanyakumari or from Arunachal Pradesh to Porbandar and including Golden Quadrilateral. So we are covering these entire, major highways. Apart from, we are working as of now around 100 plus highways to ensure that every 100 kilometer in first phase, every 100 kilometer we have a charging stations. And then in the next phase, we may go for every 50 kilometers. So that is the kind of plan we are coming up to ensure that the kind of range anxiety people talk about get eliminated completely.
Okay, sure. Quickly, sir.
Quickly, I'd like to add here. Interestingly, when I was trying to reach out to Tata Power, I was told to go to 1-800 line, and I did. That gentleman, whoever it was, he was not very fancy speaking, but he took me diligently, patiently, step by step, downloading the app and telling me now go to this part of the screen, until I reached my end point. And this was my first effort, and he says, "Ye pehla effort mushkil hoga, uske baad bahut aasan hoga. Next time you want to recharge." But go through the whole process, and they were very patient and good. That's all that I can say to
Thank you, Mr.
Let's
Pava,
have a
for the
round of
compliment.
applause for that. So we are running out of time, and in the interest of everybody, I think we should reach to a nice conclusion. I'm going to give 30 seconds to each of the panelists and understand from them as to how they or their organizations are going to contribute to the growth and progress of the EV ecosystem in the country, starting with Mr. Vani Dantam. 30 seconds.
Depending on the country, I think the EV ecosystem development is going to be, different. Some areas might do this more rapidly. For example, in India, I think the best area to do this is 2 and 3 wheelers first, and then commercial vehicles and buses, followed by automobiles. And also recycling. This is something we cannot forget.
Right.
None of us have talked about it, but we have to choose technologies where recycling is integrated into the process and recycling becomes easier. I am working with a company in India called Loham, and these folks have marvelous recycling technologies. And I'm actually very impressed and amazed at how simple and direct their technologies are. So that said, when I'm looking at the United States, California, all of us know California announced this year with only 5% penetration of EVs this summer. They said, please don't charge EVs because we don't have enough power online. So this is something we have to pay attention to.
Right.
So what happens if EV penetration goes to 20%? This is something all of us need to think about. Yes.
R.K. Singh ji?
So I think Mr. Dantam was touching upon that power requirement for charging infrastructure. So even though ministry comes up with certain policies and guidelines, but getting it implemented on the ground takes very long time.
Right.
So I would urge the industry to do the policy advocacy at every level. Okay.
Right.
Because it takes a lot of time. Power is a regulated industry. Until unless any guideline is issued through the regulator, state regulator, it will not get implemented by the DISCOM. So MOP has asked to release the power connection in the city, A-class city, within 7 days. But it takes 60 days, 30 days, 40 days, even 4 months' time. Okay.
Right.
So, because there is no regulation, nobody is monitoring that kind of, that how much time is being taken by these state DISCOMs. So I think this is one of the key point to accelerate the charging infrastructure across India, not only with Tata Power, but there are many other players also coming into this charge point operation space. Then second important point is that we also need to educate, last mile connectivity, the end users. So they are not, updated on the technologies, products, policies. so that it can enhance the adoption, EV adoption.
Certainly.
And third point is that, like first time Mr. Pahwa was telling, so I think even we as industry also need to see that how we take care of the first time users, so that experience is first time and every time is better. Thank you.
Excellent. Thank you so much. In fact, you mentioned that the industry needs to take up advocacy. One of the objectives of this platform, which Mr. Sanjeev Nikore has been emphasizing right from the beginning, is that this should not be a one-time effort. And it should not end with just knowledge sharing, but it should take the industry ahead. So, in fact, I'm happy to also share with you and everybody else that we are going to come out with white papers based on the knowledge sharing that has happened in this particular conclave. And those white papers will be shared and discussed with the right kind of authorities across the country. Okay? So, I'm sure you'll be happy to hear that. Pahwa ji, आपका time खत्म हो चुका है, but फिर भी आप थोड़ा सा बोल सकते हैं sir.
Okay. I'll summarize. In 2017, the total amount of giga capacity in the world was 70 giga.
Right.
35 concentrated in China, 35 scattered all over the world. So you can see the constraints in terms of manpower, technology, the ecosystem. And today we are already predicting more than 1,000 giga by the end of the decade, more than 1,000 operational. But I want to echo a little bit on what Mr. Vani mentioned. There is, in all this, while you have shortage of people, resources, machinery, manufacturing, interesting thing is that Indian diaspora, both here and overseas, in the material sciences is well established, and the generational change that is going to take place into the second generation of batteries that he's referring to, fortunately, I think India can leapfrog well into that, because the material scientists here in India are pretty good and working hard in the new changes that are taking place. So there will be a change, battery in technology, the material science, and the new technology, the chemistries, I would say, that are going to be coming out. And the first one we have missed. That's Chinese, all that stuff. We'll end up putting our giga plants. But the second leap that will be coming, maybe at the end of the decade, will be very much a part of all the challenges in the globe.
Sir, it was worth the time. Thank you so much. Let's have a round of applause for him there.
Thank you.
KBS.
My firm belief is that subsidizing the consumer is not a better option than actually encouraging the charging infrastructure. I think it's better for the government to encourage that in various forms, because that will drive adoption far more than subsidies at the hands of the consumers. And therefore, the points I made about initiatives required and policies required. The more important thing, coming to the advocacy thing, I think advocacy at the right time is also important. The problem with the advocacy is that if people make large investments assuming a certain direction, then it leads to lobbies, right? And then it's very difficult to steer it back to the right path. And therefore, it's very important to not only do advocacy, but advocacy early enough and in time, so that we can lay a clear path ahead, so that some of these become optimum over a period of time. Otherwise, it is a jigsaw walk. It's better to make it a straight walk.
Absolutely. Well said. On that note, we conclude this panel discussion. Can we have... Yes?
Yeah, sorry.
Question. Do we have time?
Only one question we can take.
Okay, only one question we can take.
As a user of EV, I've got question for Ramkrishna.